Fluorescent lamps require a higher voltage than the typical 120 volts household current to start. This is because the gas inside the tube is initially in an unexcited state and needs a high voltage to ionize it. Once the gas is ionized, it can conduct electricity and the lamp will continue to operate on the lower voltage. Trigger start fluorescent lamps use a starter to provide the high voltage necessary to start the lamp. The starter is a small, cylindrical device that contains a bimetallic strip and a thermal switch. When the lamp is turned on, the current flows through the starter. This causes the bimetallic strip to heat up and bend. This opens the thermal switch, which breaks the current and causes the starter to reset. The cycle of heating and cooling the bimetallic strip and opening and closing the thermal switch creates a rapid series of voltage spikes. These voltage spikes are applied to the lamp and provide the high voltage necessary to start it. Ignitor start fluorescent lamps use an electronic ignitor to provide the high voltage necessary to start the lamp. The ignitor is a small electronic device that contains a capacitor, an inductor, and a transistor. When the lamp is turned on, the current flows through the capacitor. This charges the capacitor and creates a magnetic field in the inductor. The transistor then switches on, which discharges the capacitor and collapses the magnetic field. The collapse of the magnetic field creates a high voltage pulse, which is applied to the lamp and provides the high voltage necessary to start it. Trigger start fluorescent lamps are less efficient than ignitor start fluorescent lamps because the starter draws a small amount of current even when the lamp is not operating. Ignitor start fluorescent lamps are more efficient because the ignitor only draws current when the lamp is starting. Ignitor start fluorescent lamps are also more reliable than trigger start fluorescent lamps because the ignitor is a solid-state device that is less likely to fail than the mechanical starter. To expand on these concepts, let's delve deeper into the specifics of each type of starting mechanism. Trigger start systems, while less efficient, were a common early solution. The starter itself is a simple but ingenious device. It typically consists of a small glass envelope filled with an inert gas, such as argon, and contains a bimetallic strip in series with a small capacitor. When power is initially applied, the applied voltage causes a glow discharge to occur within the starter, heating the bimetallic strip. As the strip heats, it bends and eventually makes contact with another electrode, shorting out the starter. This allows the full ballast current to flow through the lamp's electrodes, heating them up. The heat emitted from the lamp electrodes helps to ionize the gas within the lamp. After a brief period, the bimetallic strip cools and separates, opening the circuit. This interruption of the current flow causes the ballast, which is an inductor, to generate a high voltage pulse. This pulse is then applied across the lamp, initiating the main discharge and causing the lamp to light. Once the lamp is lit, the voltage drop across it is lower, and the starter no longer plays a role in the circuit. Now, let's examine the ignitor start method. These systems are more advanced and offer several advantages over trigger start systems. The ignitor is an electronic circuit that generates a high voltage pulse directly. It typically uses a capacitor, an inductor, and a switching device like a silicon-controlled rectifier, or SCR. When power is applied, the capacitor charges up. Once the capacitor reaches a certain voltage, the SCR is triggered, discharging the capacitor through the inductor. This rapid discharge creates a high voltage pulse due to the inductor's opposition to changes in current flow. This high voltage pulse is then applied across the lamp, initiating the discharge. Ignitor circuits are designed to produce a very short, high-voltage pulse, typically several thousand volts, to quickly ionize the gas within the lamp. Once the lamp is lit, the ignitor circuit stops generating pulses, and the lamp operates normally. One of the key benefits of ignitor start systems is their improved energy efficiency. Because the ignitor only operates during the starting phase, it consumes very little power compared to the continuous operation of the starter in trigger start systems. Another advantage is their increased reliability. Since the ignitor is a solid-state electronic device, it has a longer lifespan and is less prone to failure than the mechanical starter used in trigger start systems. In terms of application, trigger start systems were commonly used in older fluorescent lighting installations, while ignitor start systems are more prevalent in modern systems. The choice between the two depends on factors such as cost, efficiency requirements, and desired lifespan. It's worth noting that there are also variations within each type of starting mechanism. For example, some trigger start systems use a glow switch starter, while others use a thermal starter. Similarly, there are different types of electronic ignitors, each with its own specific design and performance characteristics. In summary, both trigger start and igniter start fluorescent lamps achieve the same goal of providing the high voltage necessary to initiate the discharge within the lamp, but they do so using different methods. Trigger start systems rely on a mechanical starter that heats up and cools down to create voltage spikes, while igniter start systems use an electronic circuit to generate a high voltage pulse directly. Igniter start systems offer improved energy efficiency and reliability compared to trigger start systems, making them the preferred choice for modern fluorescent lighting installations. When dealing with fluorescent lighting systems, it is important to understand the function of the ballast. The ballast limits the current through the lamp, preventing it from drawing excessive current and burning out. It also provides the necessary voltage to start the lamp. In trigger start systems, the ballast works in conjunction with the starter to generate the high voltage pulse needed for starting. In igniter start systems, the ballast works in conjunction with the igniter to provide the appropriate operating voltage and current for the lamp. Additionally, it's important to consider the type of fluorescent lamp being used. There are different types of fluorescent lamps, each with its own specific voltage and current requirements. The ballast and starter or igniter must be compatible with the type of lamp being used to ensure proper operation and prevent damage to the lamp or the ballast. When troubleshooting fluorescent lighting systems, it's important to check the starter or igniter, the ballast, and the lamp itself. A faulty starter or igniter can prevent the lamp from starting. A faulty ballast can cause the lamp to flicker, dim, or not light at all. And a faulty lamp can exhibit various problems such as flickering, dimming, or complete failure. Using appropriate safety precautions when working with electrical systems is crucial. Always disconnect the power before working on any electrical components, and use appropriate safety gear such as insulated gloves and safety glasses. Understanding the principles behind fluorescent lamp starting mechanisms and the function of the various components in the system is essential for anyone working with or maintaining fluorescent lighting systems. There are several important safety considerations to keep in mind when working with fluorescent lighting systems. Firstly, always disconnect the power supply before performing any maintenance or repairs on the system. Fluorescent lamps operate at high voltages, and contact with live electrical components can be dangerous. Secondly, be careful when handling fluorescent lamps, as they contain mercury, a toxic substance. If a lamp breaks, avoid touching the broken glass and clean up the spill immediately using appropriate safety measures. Thirdly, ensure that the ballast is properly grounded. A faulty ground connection can create a shock hazard. Fourthly, use only approved replacement parts for the ballast, starter, and lamp. Using substandard or incompatible parts can damage the system and create a safety hazard. Fifthly, follow all applicable electrical codes and regulations when installing or maintaining fluorescent lighting systems. These codes and regulations are designed to ensure the safe and proper operation of electrical systems. In addition to these safety considerations, there are also some practical tips to keep in mind when working with fluorescent lighting systems. Firstly, label all wires and connections clearly to avoid confusion during maintenance or repairs. Secondly, use a multimeter to check the voltage and current at various points in the system to diagnose problems. Thirdly, keep the lighting system clean and free of dust and debris. Dust and debris can reduce the efficiency of the lamps and shorten their lifespan. Fourthly, replace lamps before they burn out completely. Lamps that are nearing the end of their lifespan can consume more energy and produce less light. Fifthly, consider upgrading to more energy-efficient fluorescent lamps or LED lighting systems. LED lighting systems offer significant energy savings and have a longer lifespan than traditional fluorescent lamps. When selecting a ballast for a fluorescent lighting system, it's important to consider the following factors. Firstly, the type of lamp being used. Different types of fluorescent lamps require different ballasts. Secondly, the voltage of the power supply. The ballast must be compatible with the voltage of the power supply. Thirdly, the energy efficiency of the ballast. Energy-efficient ballast can save energy and reduce operating costs. Fourthly, the safety rating of the ballast. The ballast should be safety rated by a recognized testing laboratory. Fifthly, the warranty of the ballast. A longer warranty indicates a higher quality ballast. When selecting a starter or ignitor for a fluorescent lighting system, it's important to consider the following factors. Firstly, the type of lamp being used. Different types of fluorescent lamps require different starters or ignitors. Secondly, the voltage of the power supply. The starter or ignitor must be compatible with the voltage of the power supply. Thirdly, the reliability of the starter or ignitor. A reliable starter or ignitor will ensure that the lamp starts quickly and consistently. Fourthly, the warranty of the starter or ignitor. A longer warranty indicates a higher quality starter or ignitor. Fifthly, the energy efficiency of the starter or ignitor. Some starters and ignitors are more energy efficient than others. In conclusion, understanding the principles behind fluorescent lamp starting mechanisms, the function of the various components in the system, and the associated safety considerations is essential for anyone working with or maintaining fluorescent lighting systems. By following these guidelines, you can ensure the safe and efficient operation of fluorescent lighting systems. Moreover, it is important to be aware of potential issues that can arise with fluorescent lighting systems and how to address them effectively. One common problem is lamp flickering, which can be caused by several factors, including a faulty starter or ignitor, a failing ballast, or loose connection. In such cases, it is important to systematically check each component to identify the source of the problem. Another issue is premature lamp failure, which can be caused by excessive heat, voltage fluctuations, or improper installation. To prevent premature lamp failure, it is important to ensure that the lamps are installed in a well-ventilated area and that the ballast is properly matched to the lamp type. Additionally, it is important to avoid frequent switching of the lamps, as this can shorten their lifespan. Furthermore, it is important to be aware of the environmental impact of fluorescent lamps, as they contain mercury. When disposing of fluorescent lamps, it is important to follow local regulations and dispose of them properly to prevent mercury contamination. Many municipalities offer recycling programs for fluorescent lamps, which can help to reduce their environmental impact. In addition to these practical considerations, it is also important to stay up to date with the latest advancements in fluorescent lighting technology. For example, electronic ballasts have become increasingly popular due to their energy efficiency and improved performance compared to traditional magnetic ballasts. Electronic ballasts also offer features such as dimming and programmability, which can further enhance the energy savings and functionality of fluorescent lighting systems. Another emerging trend is the use of LED lighting as a replacement for fluorescent lighting. LED lighting offers several advantages over fluorescent lighting, including higher energy efficiency, longer lifespan, and improved light quality. While LED lighting systems typically have a higher upfront cost, their long-term energy savings and reduced maintenance costs can make them a more cost-effective option in the long run. In summary, fluorescent lighting systems are a widely used and versatile lighting technology, but it is important to understand their operating principles, safety considerations, and potential issues to ensure their safe and efficient operation. By staying informed about the latest advancements in lighting technology and following best practices for installation, maintenance, and disposal, you can maximize the benefits of fluorescent lighting while minimizing its environmental impact. The transition from older trigger-start fluorescent lamps to newer ignitor-start and eventually LED lighting represents a significant evolution in lighting technology. This evolution has been driven by the need for greater energy efficiency, longer lifespan, and improved light quality. Trigger-start fluorescent lamps, while relatively simple and inexpensive, were characterized by their lower energy efficiency and shorter lifespan compared to newer technologies. The starter mechanism, which relied on a bimetallic strip and a thermal switch, consumed a small amount of power even when the lamp was not operating, contributing to energy waste. Ignitor-start fluorescent lamps, on the other hand, offered improved energy efficiency and longer lifespan due to their electronic ignitor, which only operated during the starting phase. The electronic ignitor also provided more reliable starting and reduced the risk of lamp flickering. LED lighting represents the latest advancement in lighting technology, offering even greater energy efficiency, longer lifespan, and improved light quality compared to fluorescent lighting. LED lamps consume significantly less energy than fluorescent lamps and have a lifespan that can be several times longer. LED lighting also offers greater design flexibility, allowing for the creation of innovative lighting solutions that were not possible with traditional fluorescent lighting. The transition from trigger-start fluorescent lamps to LED lighting has also been driven by increasing environmental concerns. Fluorescent lamps contain mercury, a toxic substance that can pose a health risk if the lamps are not disposed of properly. LED lamps, on the other hand, do not contain mercury and are therefore more environmentally friendly. In addition to these technological advancements, there have also been significant improvements in lighting control systems. Modern lighting control systems allow for the automatic dimming and switching of light based on occupancy, daylight levels, and time of day. These systems can further enhance the energy savings and functionality of lighting systems. In conclusion, the evolution of lighting technology from trigger-start fluorescent lamps to LED lighting has been driven by the need for greater energy efficiency, longer lifespan, improved light quality, and reduced environmental impact. These advancements have resulted in lighting systems that are more cost-effective, reliable, and environmentally friendly. As lighting technology continues to evolve, we can expect to see even more innovative and sustainable lighting solutions in the future.